Yeah, good morning. I have some few tutorials to be given to you so that you can fill in my logbooks for me. So this is your information, please. Within this week, try and be expecting the midsem on the ProProf. Yes, expect the midsem on the ProProf. I will share the time and the day with you so that you just go there at the appropriate time and do the midsem. Right. Whether there's a problem with the ProProf or not, we shall do the midsem using the ProProf. Fine. The second thing is that this week, all my logbooks should get to me, should get back to me. Yeah, you are filling all the answers that I need before you submit them. And this is the way it will go. If I have class with you at probably today 9 to 11, I will not be coming to the class. You use that time to do all the fillings. There are some calculations too in it that you have to complete. Then Friday at 5 p.m., listen to it carefully. Friday, I think 6 should be okay. 6 p.m. You see, there is a security gate at RCs. There's a security gate at RCs. When you're going to the auditorium, there's a security gate there. There is this lover's bench under a tree there. I'll be expecting all the class reps to submit all the books there. I'll be coming there with a car to pick all of them. So all class reps, you have to keep this in touch. So collect all the logbooks which has been filled and let me have them there. So if you have not had your logbook yet, whether you've paid or you've not paid, you do the necessary arrangement with either your class rep or with Mr. Clifford. Get one, then you do it as I've instructed. I don't want to pick the books after Friday and people start calling again. No, I don't want it that way. As for C class, I'm done with you. I don't owe you any book. For the other classes, I think you are being handled by Mr. Rachel and Mr. Clifford. So you do the arrangement very well and get the books. Right. So let's go. There's this first assignment that I want us to tackle. Let me share my screen first. Yeah, so this thing, how is it? Okay, right. So when you go to page 6, there's a table there, and that's how it is going to go. We are going to draw a simple electrical circuit. Our source should be a DC battery. I will not use what do you call it? A switch here. Then definitely we will need a resistor. Resistor is under basics. You find resistor down there. You connect it. Then we look for ammeter. If you want an ammeter, it's found under indicators. You see, whenever you want to get anything, come here. Come to this group. Under this group, you have this space here. So you click on, sorry, you click on what? Basics. Then go to indicators. And the indicators, you see ammeter, voltmeter, probe, buzzer, and lamp. So we need an ammeter. So I pick the ammeter. We have the vertical connected one, and we have the horizontal connected one. The horizontal goes like this, and the vertical goes like this. So let's pick any of them. Maybe the horizontal, then I put it there. But remember always this system, you have to always use what is called an X. So where we have this group, you click there, you go to source, then get your ground there or X. So you pick it and add it to your circuit. So now we complete our drawing or we complete our circuit. So this resistor, I can click on Control R so that it will rotate. Control R is for rotation. Right, so we are done. We have to put in the values. The first point, we're told to what? To use 12 volts over here. When you read the instructions, that's how it goes. Then the resistor over here should be 100 throughout, 100 ohms. So when I simulate this, I should be able to get the value of the current, which is 0. Sorry, I think the voltage does not peak. It should be 2 volts rather. So I simulate it this way. Then I have 0.02 ampere. So you fill in the table as is in what? Page 6. Then the next step, you double click on these two, make it 4. Then you simulate again. Then you have 0.04 for what? The current. As simple as that. So I should have given you an assignment to draw something, but it's good I leave it for now because of our time. Right. So you do that, you now change it to 6, change it to 8, change it to 10 until you get all the values for the table. But for the resistance side, you are not going to write, I think in the table, the resistance side will be 100, 100, 100 throughout. But for the current side, you have to put the right values over there. Right. Now let's go to page 7. Page 7, you measure the total resistance. So you are going to do simulation as well as what? As well as theoretical. So you use theory to do your calculation because when you look at the circuit, this is how it looks like. So we have that is page 7. So let me stop it and bring my other resistor in. You just do Control C and Control V. It will copy and paste. So I have it this way. The voltage supply for this system is what? Is 12. So 12 volts. So whenever you are going to measure resistance, it's good you take off the supply like this. Don't add it to the system before you what? You take the measurement of the resistance. So remember this resistor here is 100. Then this resistor here is 470. I have all of them with me. 470. So I bring in an indicator, which is under indicators. I'm going to find, I go here, go to indicators. Then I look for my ohmmeter. Where's my ohmmeter? Okay, fine. So there's something I didn't teach you. On my right, far right, there are some instruments. The first one is multimeter. The second one is function generator. The next one is what? Wattmeter. We have what? Oscilloscope in that order. So I'll look for the multimeter. So I put the multimeter this way. I connect, you see the positive and negatives. We put the positive side top here. Then we put the negative side also down there. I simulate it, but you will not see anything after simulation. You have to do something first. I have to double click on the multimeter. But look at here. It has been set to voltage. We can set it to current. All these ones will not give you anything because there's no source. We are looking for only resistance. So you click on the resistance symbol. That's the ohm. And that is where you are going to have 82.456 ohm. So at the end of the day, you can also use the calculation to do and get the at page 7, top there, we have theoretical value and simulation value. So you do that and put it carefully. Then there's 1, 2 down there. We have another circuit down there, of which, let me close this for now. Another one down there that will want you to add another resistor. So I paste it here, which is also a value of 100. So it is in series with all these guys. So I'm bringing my meter down here. I don't need this battery. I'm bringing my meter here to connect this side, connect this side. Then we simulate. So remember this resistor here is 220. 220. Now you see this resistor and this resistor are in parallel and all of them are in series with us. So we simulate and see our values. So the value becomes 168.75 ohm. Please do the simulation and do the theoretical calculations too. All right, the last one, we are going to calculate for current, which is at page 8. There's some current that we are going to measure. So we have, it's also a simple circuit. So we rather take this off, look for our battery back. We look for our battery, bring it. Then we complete the circuit in that order. So I think I will need ammeter. Measure the total current. If I want total current, definitely I have to look for my ammeter. So ammeter is under indicators. I pick it, then I put it there. Please, most of these things will come in your practicals, and I suspect next week will be your practical exam. So prepare accordingly. So here we have 100, we have our 470 here, 470 ohm. Then we still have our 12 volts as the source. Then we simulate. At the end of the day, I have 0.021 ampere. Or you can do it 21.05 milliampere. As simple as that. Right. So we are done with page 8. We go to page 9. Page 9, we have them connected in parallel, rather. So I need to copy and paste this. Then I'll make it 100. Make it 100. This one is still 470. That's page 9, top. Page 9, top. So when we simulate it this way, we have our current as 0.146. 0.146. But if you use a different ammeter, you're going to get a different precision. This one is giving you 0.146. But when we use the multimeter, this one, it will give us a different value. Let's try that. So I'll use that one rather. I'll use the multimeter instead of the ammeter. The multimeter is the same as the avometer. So remember, we are setting this place to ampere. And that one gives us 145.53. So this is the right value. The other one was approximating. So the multimeter is actually giving us a better reading than the what? The pure ammeter. Right. Another system or another circuit is there for us to measure its current. And there we have another resistor in series with them, with these resistors. So we connect it accordingly. So this is the circuit. We have 112, we have 100 here, then we have 220 here, rather. So we have 220. So we simulate, then we double click on it. It has been set to voltage. That's why we are getting 12 volts, but we want current. So we set it to current, then we have 71.113 milliampere. So you have to keep note of all these. Now there's a different circuit. Now we want to have another source over here. Watch it carefully. This thing is critical in our society, and we have been seeing it in the society, only that we never pay attention to it. This is how it goes. The resistors are showing, or they are depicting loads or communities that will be using the power. So let's see, but these ones are the generators, the 12 and 12. So let's see, here is 12, and this side is what? 9 volts. That is, I'm working on page 10. That special circuit that you see there is very, very, very important. This is what it means. This place can be Akosombo Dam, where Akosombo is supplying power from. Then this place is Bui Dam. They are all supplying power to us. We don't have only one source now. Now we are having 2 sources. So Akosombo Dam, Bui Dam. But what is the meaning of these resistors? These resistors are just showing the consumers. So let's say the whole of this place is Ashanti region, and maybe Greater Accra side. That's the south, the south, far south. Then here becomes maybe the Bron and the Ahafo region. Then here becomes the northern region. We've just divided the whole Ghana into three loads: the south, the middle belt, then the northern territory. So the Bui Dam will be supplying from the north there. The Akosombo Dam will also be supplying from the south. Then all the loads are caught in between. So we are going to see how we can supply power to them. So if the total current through each, we have to measure the total current through each branch. So VRA will want to know how much current is coming from Akosombo 2. So there will be a time, maybe if you are doing the measurement and you are not getting the required value, then it needs repairs, as simple as that. That is why we try to do this. So let me use the other ammeter so that things will rather be simple for me. So I go there, look for indicators. I need an ammeter. I take the horizontal one, plug it here. Another one, plug it here. Then I use the vertical one, plug it in here. So I have the three. Now I have to look at how they are all generating. And the current that is coming here, remember the current that is coming here will be this plus this, because this is coming from my left, this is coming from my right. So definitely when they come together, they are going to flow down here. That's Kirchhoff's first law. So let's do that. We do our simulation. So we have 0.050, we have 0.070, they have minus 0.02. So but I think I've not changed the values of the resistors. Let me do that. 100, 100, 220. Yeah, let me do that. So this place, I don't want to mislead those who would like to copy straight from the video. So we simulate it again. Then we have minus 4.44. Am I still having? Yes, it's still wrong because this place has to be 470. 470. Yes, this is the right architecture with reference to page 10. So you have 0.011 ampere minus 0.021. Yes, then we have 0.031. Yes, but if you use the multimeter, you have different values. So this is what goes on. Somebody will ask, why negative here? Remember, current is coming from this battery in this direction. But when we were connecting the ammeter, we made the negative side connected to where the current is coming from. So always the positive side should be connected to where the current is coming from, or else you always get the negative value. So let's do that. I'm going to turn it. So I'll remove the proofs or the terminals. Then I'll do Control R and I rotate it. When I rotate it, now the positive side is connected to where the current is coming from. So when I now simulate it again, the value is expected to become positive. As simple as that. Yeah. Now we go to page 12. But in the meantime, let me upload this video for you. Yes.